This is a video in order to understand the problems on discrete time Fourier transform, considering the properties of DTFT and the simple Fourier transforms of DTFT. The properties of DTFT has been summarized as is given in this particular slide. Details of this is given in another video. Let us go on to the first problem on determining the DTFT using the properties of DTFT. The problem given is 1 by 3 power n minus 3 u of n minus 3. Using the time delay property, we would be getting this function as x of n minus nd would be equivalent to x of e power j omega into e power minus j omega into nd, where nd in this particular problem is 3. So, trying to determine the Fourier of 1 by 3 power n minus 3 u of n minus 3, we would be getting it as e power minus j3 omega equivalent to e power minus j nd omega, where nd is 3 as mentioned before, and the Fourier equivalent of 1 by 3 power n u of n. The Fourier equivalent of such a function would be equivalent to a power n u of n, which is given by 1 divided by 1 minus a e power minus j omega, where modulus of a is less than 1. Hence, the solution would be e power minus j3 omega into 1 divided by 1 minus 1 by 3 e power minus j omega for the problem 1 by 3 n power minus 3 into u of n minus 3. Let us go on to the second problem to determine the DTFT property using the property of DTFT given by the question is x of n is equal to u power minus n. Most of us are aware u of n has a DTFT given by 1 divided by 1 minus e power minus j omega. Hence, in order to get u of minus n, we would be writing it as 1 divided by 1 minus e power minus j omega at omega equal to minus omega. Therefore, the function of f of u power minus n would be f into u of n at omega equal to minus omega, resulting in x of minus n would give x of e power minus j omega equivalent to the time reversal property. Therefore, the answer would be 1 divided by 1 minus e power minus j omega into minus for the minus omega. Hence, the solution for u of minus n would be 1 divided by 1 minus e power minus j omega. Let us go on to the next problem. It is n into 3 power minus n into u of minus n. The solution is n into x of n would be j into d by d omega x of e j omega. Hence, writing it in terms of Fourier, we would be getting it as Fourier of n into 3 power minus n u of minus n would be equal to j into d by d omega Fourier of 3 power minus n into u of minus n. So, let us first try to find out the Fourier of 3 power n u of n and then differentiate it with respect to j into d by d omega after substituting omega equal to minus omega for the reversal. Hence, the expression would be for 3 power n u of n, we could substitute it as 1 by 1 minus a e power minus j omega, resulting in j into d by d omega 1 by 1 minus 3 e power minus j omega, as can be seen from this particular transform, and substituting omega equal to minus omega for this particular problem, we would be getting j into d by d omega would be 1 divided by 1 minus 3 e power j omega. Therefore, our resultant after differentiation would be j into minus 3 e power j omega into j divided by 1 minus 3 e power j omega the whole square. What would this result in? This would give us minus into minus is plus, j into j is j squared is minus, so minus 3 into e power j omega divided by 1 minus 3 e power j omega the whole square. Hence, the solution of n into 3 power minus n u of minus n would be minus 3 e power j omega divided by 1 minus 3 e power j omega the whole squared. Let's go on to the next problem on determining the DTFT using the properties of DTFT. The problem is e power 3n u of n. We would use the frequency shift property given by e power j omega c n x of n would give us x of e power j omega minus omega c. Therefore, e power j omega naught n would be x into e power j omega minus omega naught for this particular problem. Hence, writing it in terms of the Fourier of e power 3n u of n would be 1 divided by 1 minus e power minus j omega minus omega minus j into omega minus 3, resulting in the solution. Let us go on to the next problem. Determine the DTFT of x of n is equal to 1 by 3 power n u of n plus 2. This could be written as 1 by 3 power minus 2 into 1 by 3 n plus 2 into u of n plus 2. Hence, writing the DTFT of 1 by 3 power n u of n, we would be getting it as 1 by 1 minus 1 by 3 e power minus j omega, and here we have 1 by 3 power minus 2, which could be written as 9. Hence, the solution of this particular function, which is shifted by n plus 2, would be e power j 2 omega to account for this plus 2 for the time shifting into 9, which is for 1 by 3 power minus 2 into the Fourier of 1 by 3 power n u of n is 1 by 1 minus 1 by 3 e power minus j omega. Hence, the solution would be the DTFT of 1 by 3 power n u of n plus 2 would be e power j 2 omega into 9 divided by 1 minus 1 by 3 e power minus j omega. Let us go on to another problem to determine x of n for the DTFT given. X of ej omega is 2 divided by minus e power minus j 2 omega plus e power minus j omega plus 6. This would be equivalent to 2 divided by 6 into 1 plus e power minus j omega by 6 minus e power minus j 2 omega by 6. Hence, 1 by 3 would be equal to a divided by 1 plus half into e power minus j omega plus b divided by 1 minus 1 by 3 e power minus j omega, which are the factors of 1 plus e power minus j omega by 6 minus e power minus j 2 omega by 6. Hence, on substituting, we may get as 1 by 3 is equal to a into 1 minus 1 by 3 e power minus j omega and b into 1 plus 1 by 2 e power minus j omega divided by the same common value, which may be present here also. Hence, equating the constants, 1 by 3 is equal to a plus b, because here we will be getting a into 1 minus 1 by 3 e power minus j omega, and here it would be 1 plus 1 by 2 e power minus j omega for b, and 0 would be 1 minus 1 by 3 of a plus 1 by 2 of b. On solving, we get a is equal to 1 by 5 and b is equal to 2 by 15. Hence, x of ej omega on substitution would be 1 by 5 divided by 1 plus 1 by 2 e power minus j omega plus 2 by 15 divided by 1 minus 3 e power minus j omega. Hence, trying to convert it using the Fourier expression, a power n u of n is equal to 1 by 1 minus a e power minus j omega, we get the solution as x of n would be equal to 1 by 5, which is the constant for this, and since it is plus half, we will be getting minus half power n u of n plus 2 by 15, it is minus 1 by 3, so it will be the normal one, 1 by 3 power n u of n. Thus, we have determined x of n for the given problem as 1 by 5 into minus half power n u of n plus 2 by 15 into 1 1 by 3 power n u of n. References are Oppenheim and Haken.